Uh, well, good afternoon, everybody. The problem about this session is that it's directly after lunch. I'm glad that they don't provide big portions, so nobody sleeps. Well, since we will have a demo or working, coding at the second part of the presentation, but first, and since we are in the Startup Central here, I'm going to start with one thing that most startups face. Actually, this thing is changing employees and founders' life as well as some investors. So this thing is actually failure. So statistics say that 90% of startups fail, and this is the truth. And sorry for the bad news, but also another statistics from researchers in business in Harvard Business School say that 70% of startups fail. Those startups were actually backed by ventures. So it depends on the definition of the failure, so either by liquidating the assets or basically not reaching the business goals, or even not returning the return of investment. So, but the good thing is that there are a lot of stories there, and there are best practices that we can learn from. And there is this one story that I like the most, which is the company called Wasabi, and it's founded by Mark Hadland in 2006. And this company was actually specialized in analyzing personal transactions, financial data, and recommending ways to save money for the people. And then they were able to raise $700,000 at early 2017, and in the 2007, and in the same year, they were able to raise another $4 million. And they were doing great, good. As per Mark, he said that we were at that time the market leader, but only before another company called Mint started at the same year, like 9 months after Wasabi started. And 3 years later, Mint was acquired by Intuit for $170 million deal, and Wasabi shut down. So we have to understand why this happened. And according to Mark, he said that there are two main reasons that happened. The first one is Wasabi decided to build their own data aggregation tool, while Mint decided to work with a company called Udly. And when Wasabi was introduced that tool to the market, it was very late, and also the replacement wasn't very good. So it was getting wrong data, inaccurate, and all that stuff. The other thing is Wasabi was trying to build tools to make users edit their financial data in a seamless and intuitive way. But while Mint approach was completely different, trying to not allowing users to do any work. They were just automatically categorizing data, analyzing them. And although at the beginning of this automation, it wasn't so accurate data, but apparently customers like that. So basically, it was about product decisions, a lot of alternatives you have to make, and also timing. But also, if we can examine the reasons why startups fail. CP Insight has issued a report saying having the top 20 reasons startups fail. And I just put here first 10. And as you can see, the numbers don't add up to 100% because startups usually fail due to multiple reasons. But if you can look at the reason, the number one is no market need. So people tend to build things that nobody wants to use, or they kind of building or solving interesting problem from a technical point of view rather from the market point of view. Or they ran out of cash and, of course, having like a short run way. But I mean, also they can get outcompetent by another competitor, like how we saw in Wasabi example, and user-unfriendly products. They build stuff that without talking to customers, and also product without business model, and ignoring customers. And ignoring customers is the evil of all reasons to have the startups fail, because we've seen today in the keynote speech when Werner Vogels told us that AWS was able, like most of the products for the AWS, was a feedback from customers. And if that huge company were able to talk to customers and were able to get the feedback, why startups don't do this? So basically, the reasons were no time, no product market fit, ignoring customers' feedback, building things in a closed room without talking to customer. And this brings me to Steve Planks when he said, get out of the room and talk to customers so you know what you're going to build. So basically, it's a lot of product decisions and a lot of product alternatives. And when we talk about product, it's a little bit unclear from the whole, let's say, stakeholders of the team itself and the company, that what is the product? What are we building? What are we building first, and what we should avoid right now? What are the core features of my product, and which features will contribute to our success? So the thing is that we need to know what actually we're building. So whether it's an MVP or a minimum marketable feature, what should be included in the first release, what shouldn't be included. And this thing is tricky because some product owners and some managers think that they know what actually customers want. And this tend to be untrue. Like people, when they lock the room and they create something, they have to talk to customer. And this also reminds me of one of the 12 principles of Agile, the simplicity, which is when you build a product, you tend to find a lot of decisions that you have to make. And by maximizing work not done, then you tend to focus on the core things. Like whenever you try to build a feature, you have to select what should be in the next release, what should be prioritized, and what should be avoided completely right now. So, and this comes to the releasing and the releasing fast. And the thing is that the tech team is not the only player in the game. I mean, there are a lot of stakeholders in the company, like the marketing team, the business team, the management, the investors, and everybody would like to visualize your idea. They would like to know exactly what you're talking about. Even if we have a lot of specs around the product or features, people tend not to understand completely what you're talking about. And by iterating, best case is to give access to core group of customers on your beta. But even if you didn't do that and just released outside of the tech team, all stakeholders around you in the company can check your progress, and they can basically, by getting that, you get the relevant feedback, and you visualize the idea. The one important thing also, that you can secure resources, because if you keep working and working and nobody can see what you're talking about and understand, you're not able to secure the finance, you're not able to secure time and resources. And it tends to be that the time is the most precious resources, because losing time means losing money, the team spirit, and the marketing opportunity as we've seen in the Wasabi case. But also, sticking in operation and management rather than innovation and your vision. So my presentation title was talking about heavy lifting. And by heavy lifting here, I mean in general, reinventing the wheel. Trying to build tools that it's already there and it's in open source. Trying to build a service that you can acquire by integrating with a third party. And even design perfection, like let's say system design or architecture perfection, or also UI perfection. And building infrastructure is one of those, because unless you're fixing or trying to solve a very specific, unique problem for your infrastructure, you don't have to do this because it's already there, and you can use cloud computing capabilities. But also unproven assumptions, because sometimes you think that you make an assumption and you release a feature, and then you think that this is what the customers want. And then you release another feature, and you think that without collecting feedback and without collecting metrics. And you have to close this, or we have to close this feedback loop. So I will stop talking about this topic, because it's an example that I'm talking obviously on lean startup, and I'm talking about the agile and being more agile. And there are a lot of resources that we can go back to them. For example, the Lean Startup book, Paul Graham, the co-founder of Y Combinator, and Steve Blank, specifically the customer development approach. So I'm going to tell you a little bit about our company, Inventorum, and then I will tell you, at the end we have the demo, but I will tell you first our journey through from the start to building stuff and moving to AWS. So Inventorum is a company that started in 2013, and our main target market is the local retailers, the shops, and we sell our main product is point of sale, but we also, I would say, it's a modern point of sale that bring latest technology to the shops. But also we have our back-end and order management system that do more than that. Basically, we can also have the customer management, the inventory management, like a preparatory accounting, for example, preparing some reports to the shops. But also, if they want full-fledged accounting, they can integrate. They can move their data through one of our integrations to one of the biggest SaaS providers, called Sage. And also, we integrate different payment methods and hardware integration, and we can also provide them with the technology to sell online through an integration between our point of sale and also our online shops, so they can share the inventory. But when we started to work and then we started to get traction and customers, we found that after some while that we have some problems. And basically, the biggest problem is not being agile enough. And not being agile enough, it makes a lot of problems. Like you cannot try new features easily. You cannot even, you're locked in your technology stack, and you cannot able to change different technology that suits your feature or suits your case. But also, we had a lot of complex deployment. The deployment has to be coordinated, and it was very complex. We had to do the deployment probably at night when nobody used the system. And also, we had a lot of not utilized resources. But also, we found that the data grows fast, and we have to keep up with scalability and try to find ways to scale our storage. But in order to overcome, these problems, we we wanted to move our infrastructure to AWS. Before, we were having all the infrastructure on dedicated servers with self-managed virtualization. But in order to support scalability and more elastic, we had to move to the cloud. And we started the journey 2 years ago. And we started by, I mean, as you can see, the offering of AWS, they provide the instances, like virtual machines, the managed services, and containers, and also the serverless. And we tried to use the best tool for the case. But also, when you come from a legacy, from a company with a product that's existing, it's not a green field, you not only need to move the code, but you have to change people behavior. And we had to have like organizational changes in order to try to go all the way to managed and serverless infrastructure. So the first thing we did is to move everything quickly to EC2 instances, and that including application services, servers, database, Postgres databases, and some tooling. And then when we had everything on EC2, then we can able to, at the beginning, we had some fluctuation trying to find the best size of our instances and try to continuously, serve our customers better. But then the first step was to move from a hosted Postgres database to Aurora Postgres, and that allowed us to do a lot of to have a lot of benefits. Like, for example, Aurora Postgres had this separation layer between the storage and the compute. So, and they also like copy your data on 6 availability zones. So they support that even if you lost two copies of the data, it provides you like write does not get interrupted. And if you lose 3 copies of the data, read doesn't get interrupted. So we were rest assured that the data is secure and available, and also it allowed us to scale, because Aurora can give you, or it was giving us like the ability to scale up to 64 terabytes without us doing anything. So we were able to manage the scaling that we needed. But also using the replicas, I mean, Aurora can support up to 15 read replica. So we were able to have one replica that allowed us to fail over in few seconds in case the first master database had any problem, and instead of recovering in few minutes. But also, since we have this replica, we were able also to divert some of our application code to read data, basically the reporting, to read data from the replica. So we can also utilize that capacity. And then we had also to move to our files to like storage, and of course the SS3 was the first choice. So we moved all the files and all the objects to SS3, and that, I mean, SS3 provides us to provide everybody with, I guess, 11 nines of durability. So we also don't have to think about backups or anything of that. And then we limited all our new development to either ECS or Beanstalk. And we used Beanstalk for like small modules, small services. And then we were very happy when Fargate came to Frankfurt last year, because we have all our infrastructure on Frankfurt, of course. And with Fargate, you don't have, I mean, we didn't have to manage any of the, I mean, instances or scaling or any of that. Then it scales for us like seamlessly. So we also put all the new development on either Beanstalk or ECS Fargate. And then on the way, we were trying to extract some of our monolith app because, of course, we started with a monolith app. We tried to extract some of the monolith app as separate services. And one of the things is using Lambda to process images that is being saved to S3. So whenever an image saved to S3, then you trigger a Lambda function to process that image and create copies and all that processing. And we were able to remove that part of the code from our monolith app or our backend to an external service. But also not only this, but also we were trying to put, I mean, most of the new development as front end was using React and JavaScript frameworks. So, and those were basically served as static content. So we were also trying to use put them as static sites on S3 and put CloudFront in front of them that it will give us, I mean, it will give us serverless architecture, and it can scale automatically without we do anything. It will just be there. So, but also we were using CloudWatch for monitoring our apps and having monitoring the logs. So basically, this is our journey, and we're on the way adding to that and building more. But the objective for us was to just go to serverless, because when you have the serverless, you don't have to care about infrastructure, don't have to care about scaling servers, or because also auto-scaling, there are, like, we use the auto-scaling rules, but it doesn't handle the spikes. When you have a spike, for example, whenever an ad happened or someone clicked, I mean, you had like a viral marketing, and you have a spike. The spike takes some time for other services to respond. But with serverless, it will handle the spikes for us seamlessly. And then you don't also need to pay for resources. There is no idle resources. You don't provision anything. It just, you pay for what you use. And of course, the high availability. Yeah. So here's, during our journey, we also were testing some of the different architectures, and I want to share with you this one. Here I'm going to talk about building a very small service that basically every website or every startup has, which is signing up for trial. I mean, there is no startup that didn't do this service. So whenever you have your application running and you have your website on top of it, and then you build your service that provide a sign-up process. So for that, users can go to your website or web page, and that web page can be hosted on S3 with CloudFront on the front, and then the request goes to an Amazon API gateway, and the Amazon API gateway triggers AWS Lambda that saves the data on DynamoDB. And then whenever this happens, we set up DynamoDB stream that gets triggered whenever a record saved to the database. And then the stream will trigger Lambda that will, at the end, either trigger a notification for the admin or probably send email, confirmation email, or something like that to the user. So I'm gonna show you now. This part, it's highlighted. I don't know if you can see it. I'm talking about this part, which is basically back-end part of it, the API gateway, the Lambda, DynamoDB, and then notification Lambda. This is what I will have in my, my demo here. OK, so I will show some code, and this is the exciting for me. So what I have here is the project, and the project is basically only two files, this file and this one. So basically, I'm using here Service Framework. It's the Node.js framework that allow you to build the infrastructure and also do deployment and cleaning the stack and updating the infrastructure. Basically, Service Framework issue cloud formation. You can see. Yeah. That's better? Well, the application actually is two files, and I'm using Service Framework that will generate the service infrastructure for us. And there is also SAM, which is provided by AWS, that also can allow you to test your infrastructure or your application locally. But it happens that I use serverless. I don't have any, specific preference, but they both generate CloudFormation scripts for you. And I'm going to show you, this is here, what you have to do is configure your infrastructure in a YAML file. And if I go here, I name the service, and then I have I added two plugins. Basically, I use Python because this is my preference. So I added here like a plugin to allow serverless to install dependencies from requirements file, and then also expose the WSGI application. And then I defined here the table name, which will be users table. Basically, what we're only creating the records and save it to the database. And then here I exposed the app. And then here I use Python requirements installed as non-Linux only on Docker. This is some sort of configuration we don't have to care about now. And here I use cache. So whenever I install dependency, I don't have to install from the internet every time. I just need to use the cache. And here I exclude the virtual environment for Python. And then here I define the provider, which is AWS, because serverless can also work on top of other providers. And I use Python 3.7. And this is my stage. I can do development, or I would say staging, or production as much as I want. And then I specify the region, which is the Frankfurt. And I specify here the IAM rule for the Lambda in order to act on the DynamoDB. So I give it these permissions, and I give it the permissions for the resource, which is the user tables. And then I can set the environment variable, which will be the user table name that I gave. So my functions basically is very simple. I have a get user function, and I have a create user. I also divert everything else to the app, and I added here a health check for that. And I added the function for notification, which will be notifying me, and it subscribed to the Dynamo stream. So here I configure, or I enable the DynamoDB stream, and I give it user DynamoDB and stream RM. And I specify here the patch size because I get the events as an array in a patch. So I am concerned only with one event each time. And here I define the DynamoDB table. I give it the type, the attributes, and I give it the key. which is my user ID. And I also select here a billing mode, which is pay per request. And this is very exciting because this contributes to serverless architecture, because previously it was you provision read and write units. But now, and I guess it's November, AWS announced the on-demand business model. So you don't have to provision everything. You just pay per request. And then I have the table name here, the stream specification, and new and old images. I just will go here and run the environment. Before I do this, I need just to make sure that we don't have anything here on the console. So this is the Lambda page. There is nothing here. And this is CloudWatch. And also we have, if we go to API gateway, hopefully we don't have problems with the internet. Yeah, it's empty. And then I go there, I just say serverless or SLS deploy, and it will deploy. I did that before I explained the other file, because it takes a few minutes. So we'll keep it running until we look at the second file. So basically, this the serverless deploy here, it will run this file, nothing more than this, only this file. And I added here, when you see my functions here, the get user, the create user, and the app, and notify me, they are directed to the WSGI handler, and basically my plugin on the top divert everything to my app. And then here I don't have the WSGI app because basically I use Flask. So I don't need this to be an API, it's just a Lambda function that responds to the DynamoDB stream. So if I go there here, I can see my one file application. It's just one file. I'm using here the Poto3, which is the Python SDK for AWS on top of AWS API. And I'm using Flask as my framework. I have here, I get the user table from the environment variable where I set in the infrastructure, and I have the client for DynamoDB. And then I get everything on the root as a health check, just saying working fine. And if I go here to the first endpoint that I have, which is users by ID, I get the users. I only get the DynamoDB client and fetch the record from the database, and I fetch it by user ID. And then I serialize. Well, if there is a problem here, I send 404. Otherwise, I serialize the record. So the second one is creating the user, and basically very basic stuff, just getting the data from the request and saving the data to the DynamoDB. And at the same time, I return the serialized version of the thing. And here, for the notify me, it's just a Lambda function that only prints the event. So I didn't implement actually that. But in real situation, this can send, I would say, an event to SNS, or do your process access your application endpoint. So as we can see here, the SLS, the serverless framework, finished the deployment. And if we can have a look quickly here, it will update the dependency from the requirements and create a cache for my dependency, and then create the runtime. And also, it creates a package for me and upload it to the S3. It creates a bucket on S3 for me to have the deployment artifact. And then basically what it does is just deploying everything. And it gave me at the end here the name, the stage, and the endpoints. And I can get this endpoint here. to try it a bit. So I put here the some cur. So I just get the endpoint, and if I just hit my API, I just get the working fine here. And if I just create a user, it will work as well. And of course, getting the user data. And if we can go here and have a look at the console, we can find that it deployed an application named Summit Users to applications in Lambda module, and it deployed my 4 functions here: the get user, create user, notify me. And I have here, if I look to the API gateway, I can hopefully, yes, I can find here my API gateway sitting in front of the Lambda functions. And if I go to CloudWatch, I also can check the logs. But I want to look here at one of the functions that we already tried, which is create user. You get here like monitoring for free. So that's basically the number of invocations that happened during the session. So basically, we run it only once. And the duration every Lambda function took. And then if you have errors, it will appear here, and then the throttling, because you have to specify the number of pair processing, so you don't get a huge bill if you didn't want. And then you have here other also metrics. And you get all this and all the visibility into your service for free without doing anything. It was just small 2 files. And in the CloudWatch here, you can see our the log files of our invocation when we hit the endpoint. And also, you are able to see here, I would like to show you the notify me function, which actually get triggered not by my endpoint, but with the DynamoDB stream, which we only printed the event. And if we can go to DynamoDB, we can also see the table created for us here. This is the table here, and we have the ARN of the DynamoDB stream. So basically, it deploys everything, and we can just now, if we want, we can just clean everything by removing the data, removing the stack. So just you go SLS remove, and it will destroy everything. Everything we created will get destroyed. One last thing I want to mention here is the cost of what we've just built. So everything is built on serverless, and everything is pay as you go. And we use the API gateway, we use the Lambda and DynamoDB. And according to the published pricing for AWS, basically these pricing were for Frankfurt, of course, because we hosted everything on Frankfurt. And there is a free tier. For example, there is 1 GB free tier transfer for the API gateway. For Lambda, your first million requests or invocation will be for free. But after that, the second million will be $0.2. And then you get, because we selected the provision, the on-demand DynamoDB, so we pay per write and reads. There is no capacity unit to provision, so you pay $1.5 per million write for DynamoDB. If you calculate everything for 100,000 signups, hopefully you get the 100,000 signups on your application every month, then you only pay $1.39 a month. So This is everything from myself. If there is any question, I'm glad to answer them. Well, thank you very much for having me here. Thank you.